Welcome to This Explainer. Today, we're diving headfirst into one of the absolute wildest stories in modern tech. We're talking about a company that has just skyrocketed to a market valuation hovering around $4 trillion. $4 trillion. I'm talking, of course, about Nvidia. But look, we aren't just going to sit here and stare at a stock ticker today. We're going to deconstruct the actual mechanics of their fortress. How exactly did they build this thing? And who are the armies gathering outside the gates right now, trying to tear it all down?
All right, let's kick things off with a number that is just staggering, 80 to 90%. That represents NVIDIA's estimated share of the global AI accelerator market right now. Think about that. In a world where generative AI has fundamentally shifted the entire global tech landscape, high compute infrastructure is arguably the most valuable resource on the planet. And NVIDIA, well, they're supplying almost all of it. In an era where tech dominance is usually chopped up among a few key players, holding up to 90% of the world's most critical hardware is essentially having a monopoly on the future. The stakes we're talking about here are absolutely massive.
So to understand how they got here and if they can actually hold their ground, we're using a moat and the siege roadmap for this explainer. First up, the AI gold rush. Second, building the hardware moat. Third, the CUDA software trap. Then we'll check out the siege outside, the hyperscaler threat, startups and memory walls, and finally we'll wrap with the future of AI. Let's jump right in. Part 1. The AI gold rush. Okay, so the meteoric rise of generative AI basically created this overnight insatiable enterprise demand for high compute infrastructure. Training large language models requires a scale of data processing that literally didn't exist just a few years ago. But here's the thing. Nvidia didn't just stumble into this gold rush blind. Long before AI was every boardroom's favorite buzzword, Nvidia built its foundation on decades of absolute dominance in the traditional desktop GPU market. They commanded a massive 88% share compared to AMD's 12%. They spent years honing their silicon manufacturing, building developer relations, and optimizing hardware in the gaming and graphics world. And that gave them the absolute perfect springboard for the AI revolution. And driving this relentless push is their CEO, Jensen Huang. His management style is, well, it's incredibly unique. He kind of throws out rigid, long-term plans in favor of constant learning and just extreme efficiency. In a recent chat on the Lex Fridman podcast, Huang talked about his absolute obsession with eliminating waste. When speaking about idle power in computing, he literally said, "I want to evacuate it as fast as possible." This philosophy of extreme efficiency, it trickles down into every single piece of silicon they design. Which brings us to part 2. Building the hardware moat. Let's transition inside NVIDIA's fortress for a second to explore how they evolved from just selling individual components to selling a complete, highly integrated ecosystem. Think of NVIDIA's moat like a giant layer cake. The bottom layer is hardware verticalization. They don't just hand you a GPU and wish you luck. They sell you an entire integrated system, like the DGX SuperPod, which totally simplifies deployment for these massive AI clusters. The middle layer is the network advantage. And guys, this is crucial. When you link tens of thousands of GPUs together, the bottleneck isn't usually the chip itself. It's how fast those chips can talk to each other. By acquiring Mellanox, NVIDIA took control of InfiniBand and high-speed Ethernet networking, basically ensuring their GPUs communicate with absolutely minimal latency. And that top layer, that's the software, which we're going to dive into in just a minute. But altogether, this full-stack integration creates a performance floor that makes competitors' modular systems feel, honestly, pretty fragmented. Now, when we look at objective benchmarking data from silicon analysts, comparing raw throughput in T-flops and inference speeds across the heavy hitters, the picture gets really interesting. You've got NVIDIA's H100, their upcoming B200, and AMD's MI300X. While competitors like AMD are definitely pushing incredible hardware that absolutely competes on raw specs, NVIDIA's integrated approach, that layer cake we just talked about, means they aren't just winning on raw numbers on a spreadsheet. They're winning on how efficiently those numbers actually translate into real-world AI training performance. Moving right along to part 3, the CUDA software trap. Okay, this is arguably the deepest, widest, and most defensible part of NVIDIA's entire moat. If you want to understand NVIDIA's power, you have to understand CUDA. Launched way back in 2007, the Compute Unified Device Architecture is a universal parallel computing platform. What does that actually mean for us? It basically allows developers to break incredibly complex problems down into thousands of tiny tasks that the GPU processes all at once, instead of one by one. If the H100 chip is the engine of the AI revolution, CUDA is the operating system running that engine. NVIDIA played a brilliant long game here, handing this platform to researchers and developers for nearly 2 decades, way before AI was the cash cow it is today. And here is the crucial takeaway: vendor lock-in. Because CUDA has been the standard for so long, literally millions of lines of code have been written using its libraries. Academic research, major open source frameworks like PyTorch and TensorFlow, massive enterprise systems, they are all deeply intertwined with Nvidia's proprietary architecture. So even if a competitor like AMD comes out with a fantastic hardware alternative and pushes their open compute ROCm platform, developers face a massive headache. They prefer the reliability of an ecosystem that is mature and battle-tested. Moving away from CUDA means monumental effort in porting software, risking downtime and taking potential performance hits. For most enterprises, saving a few $1,000,000 on competitor hardware just isn't worth the nightmare of breaking their entire software pipeline. And that, my friends, is a very definition of a trap.
Part 4. The hyperscaler threat.
So if CUDA is the moat, let's pan out for a second and look at the siege happening outside. Interestingly enough, the biggest threat to Nvidia actually comes from its own best customers, the hyperscalers. We're talking tech giants like Amazon, Google, and Microsoft. They are aggressively developing their own custom in-house silicon, like Google's TPU and AWS's Trainium. Why? Well, it comes down to cost efficiency and supply chain control. Buying Nvidia GPUs at scale is a massive capital expenditure. Custom chips, on the other hand, are highly optimized for specific workloads and power consumption, which makes them absolutely fantastic for inference. That's when an AI model is already trained and is just running and generating responses. But there is a big distinction here. Nvidia's general-purpose GPUs remain the undisputed kings of training, that highly complex, heavy-lifting phase of actually building the AI model in the first place. So the hyperscalers are definitely making ground, but for the hardest tasks, they still rely heavily on Nvidia. Which takes us to Part 5, startups and memory walls. Now, the tech giants aren't the only ones trying to breach the fortress walls. We're also seeing a wave of venture-backed startups entering the fray. You've got these incredibly ambitious, well-funded companies like Grok, Cerebras, and SambaNova designing some seriously fascinating compute architectures. They're trying to challenge the status quo from the ground up. But they are all running headfirst into a massive physical limitation known as the memory wall. Think of it like this. It's like having the most powerful sports car engine in the world, but your fuel line is the size of a drinking straw. AI models are getting so huge right now that the bottleneck isn't doing the math anymore. It's physically moving those massive amounts of data in and out of the memory fast enough. Overcoming that physical bottleneck requires exactly the kind of tightly integrated network and memory architecture that Nvidia has spent the last 10 years perfecting. Finally, Part 6, the future of AI. So where is this multi-trillion-dollar industry actually heading next? Well, Nvidia maintains its massive lead, not just by reacting to the market, but by predicting it. Let's go back to Jensen Huang's chat on Lex Fridman for a second. He pointed out how Nvidia foresaw the current wave of AI architecture. He mentioned that 2 years ago, long before it was all over the news, he was already presenting schematics for agentic systems that exactly reflect OpenClaw today. Just think about that timeline for a second. This uncanny ability to predict software and AI architecture trends years before they actually happen allows Nvidia to design the hardware the world's going to need tomorrow, today. It's a strategic advantage that is honestly hard to overstate. So, what does this all mean for us? We're left with a really fascinating tension here. On one side, Nvidia has a brilliant hardware ecosystem, the incredibly deep software moat of CUDA, and visionary leadership. But gathering against them are the bottomless pockets of the hyperscalers and the agile, ground-up innovation of new startups. So here is the big question to walk away with. Will the future of AI remain an effective monopoly controlled by a single, brilliantly integrated company, or is it inevitably going to fracture into a diverse, multi-vendor landscape? It is arguably the most consequential question in technology today, and how it plays out is pretty much going to define the next decade of innovation. Thanks so much for joining me on this explainer. I really hope this helped demystify the incredible world of AI hardware for you.